Okay. Hi, everyone. We are group 64. I'm Andy.
I'm Kevin.
I'm Lily.
So today we're talking about our project emulating Spark RDD. So the reason we choose this project is because we all have little experience with this powerful distributed database system. So we decided to have a try. And we split our project into 4 parts. The first part is the class RDD, and the second part is class task and class task status. And the third one is the scheduler monitoring system. And then we have our web user interface. So first of all, we first create a RDD class, which mainly we aim to like emulate the database system, and it supports so we have 19 basic functions, which contains the basic math functions like minimum, maximum, sum, or an average, and also some like the most important function in the database system like map, filter, and reduce. And then we also have functions like sort, take, and also distinct, which can apply to further analysis. And we also have the aggregate. And then the other important part for our RDD is that it also creates partitions. We have 2 functions for that. So the first one is get partition data, and then the second one is get partition location. These 2 functions are when you run those functions, they will like split your data into several number of partitions, which based on the user input, and then they will they will be stored in to store them in different locations. And then you can use the get partition location function to get the location for different pieces of the data we store in the system. So this partition function helps the system to reduce the data transfer time and cost, as well as the workload for the processor. And for the task and task status, for these 2 classes, they hold the basic information for each task, such as their metadata, and they have a unique task ID. And then for each task, they also recorded the function each task used, and also their processing time, the submission time and the completion time. And the task status function just hold the the task status, which we have 4 stages, which is pending, running, complete, and failed. This will help us to monitor each task progress and complete status. And then I'll pass to Kevin to talk about our scheduler monitoring system.
I'll explain class SC for today. We have developed the class SC to emulate the Spark context class. First, we have implemented the parallelize function that allows user to create RDD data frame from CSV file or Python list. The class also supports the RDD class for handling the RDD datasets, as well as a task class for managing individual tasks. The SC class is designed to be used in conjunction with these other classes such as tasks, task schedulers, to facilitate distributed data processing tasks. Okay. The two main functions that I'll explain from SC class are start scheduler and submit task. The function start scheduler this method starts the scheduler and initializes the worker process. It also tests communication with the worker process by sending and receiving messages through sockets. We use the Python socket class. And the second important function I'll explain is the submit task. This method submits a task to be executed by the worker process. This submit class method takes a function and its arguments as input. The task is assigned to a unique ID, and its status is updated based on the execution result. And this is our worker loop. The submit task send the task by using sockets and data pipeline to the worker loop, and we run our RDD operations there. I'll explain the data cycle, the job cycle, data job cycle. Here, I want to explain the job cycle about our tasks. After user have input the task and the data, we use the submit task method and pickle to serialize our tasks and data, then pipeline it into different work nodes, which these several work nodes combine as a worker loop. At these worker nodes, we deserialize data at the worker loop, and then we run our tasks by calling the RDD class. After we calling RDD class, we will get the results data. But these result data are at worker loop, and we want to transfer it back to the submit tasks. From the results, we serialize these results and then pipelining back to the submit tasks and then deserialize. This is a way that how we get a deserialized result and back to our submit tasks. And for web UI, I will pass to Lili.
Okay, all right. I'm Lili. I'm gonna to introduce the web UI of our project. So as my teammate said, we have built the RDD class and SC class in our emulation system. So on top of them, we also build a web UI to monitor the system to get to know what happened in our system. So ideally, we want to present the summary and details of all jobs running our emulating systems, and we also want to display the stage and also the storage system and the storage page in our web UI to display the monitoring and the jobs processing status of in our web UI. Yeah. So that's the idea plan we want to build in the web UI. So right now I'll pass to Kevin. I'll pass to the Andy.
So this is our script of our project. So as you can see, right here we have 4 classes and 2 standalone function, which is class RDD, task status, task, and SC, with the 2 standalone function, worker loop and run task. For this project, we used pickle socket and also multi-processing and also struct for the data serialization and pipelining. So as I just talked before, we have 19 functions, which is on the database operations. Like we have partition data and get partition locations, which this one will take the data and we'll do the partitions and then return a subset. And then for the get partition location, you will return the location for each piece of data you stored in our system. And then for the map, filter, and reduce function, which they all allows you to apply your own function and then returns a new RDD for its result. And then the function like mean, minimum, maximum, and then right here the average and sum is just the math. It's just the math function that you will print the minimum, maximum, or average and sum for the Python list. And then we have group by and sort, and then reverse sort, which just like the reverse is true and reverse is false. And they all return a Python list. And then the collect function is used to collect the data from RDD and then store it into a list, and we call it result. And then and this is like all the RDD functions and their bit database operations. And then so how do we run it? So at like just like what Kevin talked before, we'll like go through all the job cycle, and then for here we set a global value which is called the job list, and this is for storing the metadata for each like the function we call like to store each task's metadata into this into this Python list. It will be a list of dictionary. So for the run task function, we will first set the task status into running, because we are basically run the task, and then we set the submission time like before they run the function, and then we set all the parameters, and then also we set the finish time when they output the result. And right here for the metadata is we created a dictionary which applies all the parameters and then like details of the task, which and then we will append it to the the job list, which that will be the metadata for the task, which will help us to connect to our web UI. And then it will be the same for all the functions with like small adjustments, which makes yeah. And then so like for test, like to show how our like text will output, we just like created 3 basic functions. So these 2 are specifically for the aggregation, the function aggregate. And we create a simple function called double, which is each value in the list will times 2. So and then we create a function called run, which include all the test code we have. So we first set our class SC to test app, and we have three partitions. And then I just use the data like we'll have 20 different numbers between the range 1 and 100, and then we just do parallelize, which because it's not a file, so file name equals to none, and then number of partition equals to 3. Then we start scheduler, and we have the first we have the first task, which is map, and then we use the double the double function on our RDD object. And then the second one is to print the minimum, and then the third one is to take the first 4 first 4 item from that Python list, and then I'm sorry, from the RDD, and we'll return a Python list. And then the fourth one is to just calculate the sum. And because all the tasks will like append their metadata into our job list, so I'll just like print a job list to see whether our code is working, and then we just stop our scheduler, and then and then we run it. So it will be so for the output of our data, so like first we printed a schedule start, which shows that our scheduler has started, and then it connects to 3 worker nodes. Like we set our port to 8000, so it will be 8000, 8001, and 8002. And then we connect it to our local server, and then it provides the IP address and then their worker node. Well, these prints are like simply to test if we successfully connect it. And then as you can see, this is like the result one's metadata, which contains a task ID, which is 1, and then task description, which is map, And then we print this because we're like it takes a RDD object, and then we have a submission time, finish time, and then the total runtime is just like the subtraction, and which because it takes really short time, so it's 0, and then it shows complete because we successfully print the output, so it prints like task status dot complete, and then the same for the second one and third one and fourth one. And then for here you can see that we have already like add all the metadata into the job list. So right here is task ID is 1, and then task ID 2 and 3 and 4. So it shows that our code, which like the run task and the call our RDD function, runs successfully, and then we finally print the schedule stop to stop our schedule. And then I'll pass to Lili Zhou to show like to do a brief presentation for our web UI code.
Yes, sure. Yeah. Thank you, Ziwen. So right now I'm gonna share my screen to tell you the web UI part of our project. So let's first take a look of the. So let's take a look of our web UI, the script. So we use the Streamlit to build our web UI because it's very convenient and it's very easy to connect the UI with our the code we wrote about of the RDD and essay. So we import the code the script we developed to emulate the our Spark, and we import the SC class and task status and run task. And for this web UI, our basic idea is to display the jobs, like all of the jobs running in our systems, and to display their task ID and task description, submission time, and finish time, total runtime, and also the task status. So as Ziwen said, we have created some few test tasks, like the run function. Like we have the 4 tasks. So we used these 4 tasks to display to test our web UI as well. So we used the run test task. So right now I'll jump to the terminal to run our web UI to see what's going on our web UI. So here's our terminal. Screen run our web. Yeah. So yep, here you go. It takes time. It takes time sometimes for the task to running. So but right now it's working. So as you can see, here is our very simple the web UI of our project. So here's the actions. We can see the view jobs. We can take a look all of the jobs running in our systems. Those 4 are the tasks which Ziwen introduced previous. So we can see there are 4 tasks, and we can see each of them, their task descriptions, their submission time, finish time, and total runtime, and task status. So this one is it's a very simple one to display all of the jobs running our systems. And in our future work, we are going to plan to display more, like the stage, to display a different stage of our jobs, tasks, and also the storage page, including the storage level, storage size, etc. Yeah, so yeah, that's that. So I think this is the brief introduction of our web UI part.
Yeah, that will be all of our project detail. Our project is definitely have spaces for improvement and more implementation. Well, so far we have developed our class RDD, class SC, and also for our monitoring scheduler monitor system. I believe there are still spaces that we can improve in our scheduler as well as the web UI. And that will be all. Thank you.